interatomic forces. Interatomic forces are stronger than molecular forces, and these are responsible for the stability of solids and molecules. Intermolecular forces could be of two types, that is attraction and repulsion. Because of attractive intermolecular forces, you see bond formation takes place. The force of attraction between ions is also an example of these forces. Repulsive intermolecular forces arise because of the overlapping of electron clouds when the atoms are brought closer. In fact, this is the outcome of Pauli's exclusion principle that clearly says that no two electrons can have all the quantum states similar. You see, because of these repulsive intermolecular forces, the possibility of collapse of atoms also is avoided. The types of interatomic forces have been shown over here: electrostatic, covalent, metallic, van der Waals, and so on. We have an idea of intermolecular force changing with the distance. Even its nature also changes at a particular distance. So, with the help of a graph between force and distance, we try to convert it into potential energy and distance. While drawing this curve, we have considered one molecule, one atom at point O that is fixed, and the other atom is brought from infinite. Gradually, it approaches the molecule that is fixed at O. You see, at a particular distance, the force of attraction starts, increases. Ultimately, it becomes maximum. And then all of a sudden, the force becomes zero at a particular distance. That's known as equilibrium distance. When the force becomes zero, obviously, the potential energy would be minimum. That is shown over here, corresponding to this very distance, which will be known as equilibrium distance. The potential energy is minimum here. And then if you go on reducing the distance further, that means it is further approached, then force of repulsion starts, and at a particular distance it becomes too big repulsive. That means beyond this the atoms could never approach each other. This would be known as distance of closest approach. If you consider the total energy, total mechanical energy, which is the sum of kinetic and potential, you will find here that minimum is the potential energy. So, corresponding to this very distance, the kinetic energy is going to be maximum. Here, since the potential energy has become too high, the kinetic energy will become almost zero. That means the atoms have stopped over here. Between the two, there would be a position when both energy will be equal also, but these two distances are of much importance. Here the kinetic energy is zero, here the kinetic energy is maximum.